For commuting to school or college, most of us usually take a bus ride. Let's say your school or college is 5 miles from your house. Your bus needs a gallon of fuel to cover this distance. Depending upon the size of the bus, it can hold around 40 to 60 gallons of fuel when filled completely. Now consider you are going on a field trip to another state on a bus ride. Your bus can travel a maximum of 350 miles before it needs to refuel at the next gas station. Now imagine if NASA or any other space agency want to send a space probe that is almost the size of a large SUV or a minivan to the moon or very far distant planet, which is usually a millions or even billions of miles away. How much fuel the space probe can hold? Is it safe to assume around 40 to 50 gallons? A space shuttle is needed to carry the space probe. Usually, a large space shuttle can hold around 500,000 gallons of fuel. Keep in mind that most of the fuel will be spent by the rocket boosters just to carry the probe away from the Earth's atmosphere. After the work of rocket boosters are complete, they separate from their payload, which is our space probe, and the boosters will drop back into the Earth's ocean. With a very limited amount of precious fuel stored into the space probe's thrusters, the journey has barely begun. From there on, how does the probe journey through millions and billions of miles with such a little amount of fuel stored with it? Well, Sir Isaac Newton has already solved this puzzle for us in the 16th century. When Newton was sitting on the bench and enjoying his evening, he visualized a significant fact about all the objects that were around him. He came up with the first of his famous laws of motion 400 years back, which is the main reason for the modern science to be able to put a space probe into a billion miles journey. What did he say about all the objects in his first law of motion? He says, an object in motion will remain in motion. So, according to Newton, if an object such as a ball or a bus is put into motion, it should stay in motion forever without stopping. Why does the bus stop after drying up its fuel? Why does the ball fall down on the ground and stops rolling after it is thrown away into motion? Is Newton crazy enough to say such things about all objects that are in motion? Well, he isn't. He also mentions that an object in motion will remain in motion unless an external force is acted upon it. In case of our bus or the ball, the external force is the wind blowing from the opposite direction of those objects' motion. Therefore, at one point, the wind completely stops the object's motion. There is also another external force that is constantly acting upon these objects, that is friction. Even if there is no or less wind around, the friction continuously acts upon the wheels of a bus or a rolling ball to make them eventually stop after some point. The bus keeps spending the fuel to overcome the friction and wind around us until it runs out and stops. Let's come back to our space probe. Here, the scenario is entirely different. Space is surprisingly strange from our Earth's atmosphere. Space offers one great benefit to the space probe which our Earth's inner atmosphere cannot offer. That special benefit is nothing but vacuum. At an altitude of around 6,200 miles or 10,000 kilometers above the surface of the Earth, the final air particles of our atmosphere are left and the absolute vacuum of space begins. From there on, no external force such as wind or friction can act upon the space probe. The space probe can travel continuously in motion without stopping. Except there is also one more special thing available in space to give the space probe a much needed boost for traveling a great distance. That thing is called gravity. The answer to the mystery of space probe traveling billions of miles very quickly is nothing but gravity. Yes, Gravity is the only thing that is fueling our probes in space that pushes them to travel unimaginable distance at such a high speed. All the objects which has mass exhibit gravity. Heavier the object, stronger the gravitational force it exhibits. Our scientists in NASA make use of this principle. Using the spin of the planets, we can able to either reduce the speed of the probe or boost their speed. Jupiter is considerably a large planet in our solar system, so it exhibits a huge amount of gravitational force. If the space probe is made to fly against the gravitational spin and direction of the planet like Jupiter, the probe will decelerate. Whereas if the probe is made to fly by with the gravitational spin and direction of the planet, then the probe will accelerate. Therefore, by swinging through the gravitational field of a planet, the space probe will get a boost up in its velocity and starts traveling at a tremendous speed towards the vastly distant interstellar space. The point to be noted here is the velocity of these probes will not reduce and nothing stops the probe unless or until they come across any gravitational force of another planet, asteroid or space object. The fuel will be spent by the thrusters only for telemetry adjustments during the gravity assist. Once the probe swings by the planet, it won't require any fuel to carry on with its journey until further telemetry adjustments are required once it reaches its far destination. These flybys should be timed perfectly, and the angle at which the probe flies towards the gravitational field of the planet is very important. Slightest miscalculation will result in risking of the probe deviating from its desired path, or even worse, the probe may be attracted to the gravitational field of the planet and then enter and burn into its atmosphere. This flyby technique is what we call as gravity assist. NASA have been using this gravity assist in quite a lot of space missions lately. Mariner 10 mission, launched in 1973, was the first mission to use this gravity assist technique. The Mariner 10 space probe traveled to Venus and Mercury using the gravity assist from the Earth. After that, Voyager 1 and 2 space missions in the late 1970s used the gravity assist of Jupiter to swiftly fly towards the interstellar space. The New Horizon mission, which recently had a flyby towards the planet Pluto in 2015, also used the same gravity assist technique. We might be launching quite a number of space probes into the vast distance of space in near future. Thanks to Newton, without his laws of physics, these space missions would not be possible.